Hello everyone. So welcome back to yet another session on number system. Okay, so do you remember what we had done in the previous session? Well, if not, let me give you a real quick brief of what we had done, right? Okay, these all numbers, for a deep explanation, you will have to go back to the recording and look into it. I'm just giving a brief introduction of a brief summary of what we had done, right? Okay, so let me start with, okay, so those whoever have watched the recording previously, do you remember what were the numbers which were starting with this called as, and this was so on? Well, they were called as, yes, natural numbers. And how were they represented? By the letter N. So I am just writing N over here so that you remember how do we represent them. And after that, what were the numbers that were coming after the natural numbers? Well, a 0 was added into it. 0, 1, 2, 3, and they go on and on and on. Do you remember what were the numbers called as? They were called as the whole numbers. Okay, so now we know natural numbers, whole numbers. Okay, so after whole numbers, the numbers which were there that were not there in 0, 1, 2, and 3. You guessed it correct. Where are the negative numbers? They should be somewhere, right? And of course, 0, 1, 2, and so on both the sides. Well, these numbers were called as, did you guess it? Well, integers, did we represent them with I? No, right? Z, Zellen. In German, meaning to count numbers. Yes. Okay, after this, what were the next numbers that were not there? You remember these numbers when there was 7 over 8 minus 4 over 6, 0, 1, minus 10, and so on. Do you remember what were they called as? Yes, they were called as rational numbers. How did we represent them? With, right? Okay, so there were, after rational numbers, there were some type of numbers that were not there. Do you remember what were the types of numbers that were not there in this number system? I hope you guessed it. Those numbers were irrational numbers. That is why we did not represent integers with I, right? Those were irrational numbers and represented like 2, root 5, root 11, and these were separated because there are no numbers like these. So now we know about, okay, and what was the representation? Do you remember the representation of these numbers? Well, I, irrational numbers. Okay, now we had done all of this, but do you think there is any system which includes all of the types of numbers that are there? Where rational, irrational, whole, natural, everything is included. Can you guess what that number system is? So I tell you, that number system is called as the real number system, which we represent with R. The set of real numbers in which everything is included. So we put a real big circle over it because it is covering all the types of numbers that are there in our system. Everything is covered in these set of reals, be it rational, be it irrational, be it natural, whole, or whatever. Everything is there. So now we know all the type of numbers that we had covered. But do you remember there were a few more type of numbers that were there? Well, I show it to you. These. This was your homework, you remember? Yes. So have you found 1, 3, 5, 7, and 9? What are these type of numbers? Well, if you don't know, let me tell you. These are called as odd numbers. Odd numbers. And what about 2, 4, 6, 8, 10? What is this? Isn't it the table of 2 going on and on and on? Yes. So all the numbers that are going on the table of 2 are called as even numbers. Even numbers. And what about 2, 3, 5, 7, 11? Doesn't seem to make any sense, right? Let me tell you. See, 2, when we want to divide 2 fully, which are the numbers it can be divided with? 1, 2. Similarly, 3, 1, 3. 5, 1, 5, 7, 1, 7. And so on. 11 also, right? 1 and 11. So the numbers which can be divided either with 1 or the number itself, those are called as, any guesses? Prime numbers. Prime numbers. Okay. So do you think there can be any more other type of numbers that could be there in our system? Any guesses? All right. So let me tell you what are the type of numbers that can be other than this. Okay. What if there is a 4 and there is a 6, there is a 8, there is a 9. Can you see? After 2, 3, there was no 4, but here is 4. After 5, there was no 6, here is a 6. After 7, there was no 8 and 9 and also 10. Then there was 11. So what are these type of numbers? Well, let us break them apart other than the number itself and 1. 2 2s are, right? 2 and 2. 2 3s are, 2 4s are, or 2 times 2 times 2. Whatever we can say. 3 3s are, and other than that, 2 5s are, right? So the numbers which are going on other than 1 or the number itself, that is other than the number itself and 1, are called as composite numbers. Composite numbers. So these are other 4 types of numbers. The numbers which go on the table of 2 can be divided with 2, even numbers. The numbers which are not divided on the table of 2 cannot go on the table of 2, odd numbers. The numbers which can be divided either with 1 or the number itself, prime numbers. The numbers which can be divided with the numbers which are not just 1 and the number itself, but the other numbers as well, are the composite numbers. So these are little more numbers that we know about. Now what next? You remember the other homework? Well, the 5 rational numbers between 3/5 and 6/5. What can they be? So for that, what we have to do is, let us write 3/5 and 6/5 over here, right? Okay, now we know, yesterday we learned that there can be many numbers between 2 numbers, infinitely many numbers, right? So how can we find that? There is a very, very easy way. Just multiply and divide it with 10. We saw it yesterday, you remember? Okay, so what are we going to get? It becomes 30/50, and this becomes 60/50. Now, what are the numbers that can be between 30 and 60? So many numbers, right? Like 31, 32, 33, 34, and so on. And over it, we just have to write 50. Very easy peasy way, right? Okay. Over 50, and how many we have to find? They're saying 5, but we can even have more than 5, right? So 34/50, 35/50, like so we can take. Okay, what if you don't want to go with 10? Well, you can even multiply and divide with 100. Do you want to see how? Okay, let us go a little deeper into this. For that, let us take 3/5 again and 6/5 again. But this time, let us multiply them with 100 and divide them with 100. And same goes here also. After this, what is the answer that is coming to this? 300/500 and 600/500. Now, what are the numbers existing between 300 and 600? Oh my God, there are like 300 even more numbers. 301/500, 301 over 500, 302 over 500. Well, we can take the numbers even before 600. You remember, can you tell what are the numbers before 600? Well, 599 over 500, 598 over 500, and any random number between 300 and 600. Well, isn't it 400 also coming? So any number, how many ever numbers are told, just multiply them with either 10 or 100 or any easy peasy number that you can find out, right? And write the numbers in between, whatever they are. You will be easily able to find out any rational numbers between any two rational numbers. Okay, so now this must have been easy, right? Let us go to a little bit of difficult part. Now, what is that part? See here. 5 rational numbers between 2 over 3 and 6 over 5. What is the difference between this statement and this statement? Can you see the denominators here? Here it is 5, here it is 5. Denominators are same. Here, the denominators are not same. So when the denominators are not same, what are we going to do? What do we do when we have to add or subtract, fractions? We make the denominator same. But here we are not going to do adds and subtractions. We are just going to make the denominators same. So how did we do this? The number is 2 over 3. The other number is 6 over 5. Now what is the LCM of 3 and 5? 3 ones are 3. And then 5 ones are 5. So the LCM is 3 5s are 15. So below both the numbers, there should be 15. How can we make this 15? Multiply it with 5. 5. Multiply this with 3. 3. And what are we going to get? Yes, we are going to get here 10 over 15 and 18 over 15. Okay, now the denominators are same. Everything has become same as this one. What did we do when the denominators were same? We just multiplied with 10 divided with 10, or we can go with even 100. Now, the same thing we have to do again when we have the numbers. So we have 10 over 15, we have 18 over 15. We just multiply and divide it with a 10 here also. So what are we getting? We got here 100 over 150 and 180 over 150. Now you don't need to take care of any denominators now. We know the denominators is always going to be 150. Just find out the numbers between 100 and 180. What are the numbers between 100 and 180? Well, any number can be taken, right? 101, 102. Okay, 180 before 180, 179, 178, and any random number we can take 150. Oh, 150 over 150, can't we? Isn't it interesting? Yes. So 150, 150, 150, everywhere 150, right? So we found 5 rational numbers when the denominators are not same. Great. Now this must have been clear to you, right? Let us come to another thing. Now you know what are the type of numbers. Such a big diagram of what are the type of numbers. But do you really understand numbers? Let us check. Okay. Now you will have to tell me if these things are true or false. Also, what is the reason behind them? We have to think about that, right? First is every natural number is a whole number. Okay, so what do you think? Every natural number is a whole number. Will that be true? Every natural number being a whole number. Do you feel that a figure is necessary for this? Do you know now how to make a figure of the one that we made previously? Well, if you don't remember what it was, then let me just bring it over here to you so that you remember how to go about it, how to remember and how to check if the things are true or not, right? Okay, so let me bring down this figure for you. Here it is. Can you see this? Magically appeared, right? Okay, so every natural number is a whole number. What do you think? Every natural number is a whole number? Well, natural numbers are 1, 2, 3. Whole numbers are 0, 1, 2, 3. So in the whole numbers, is this little small yellow circle coming? Is it fully covering it? Yes. In 0, 1, 2, 3, all the 1, 2, 3s are covered. So it is a yes, true. Then every integer is a whole number. See, in integers there is minus 1, minus 2, 0, 1, 2, 3. In whole numbers there is 0, 1, 2, 3. So in integers 0, 1, 2, 3 and so on is coming, right? So do you think every integer is a whole number? How is it true? Do you think minus 1, minus 2, minus 3 are whole numbers? No, right? So every integer is not a whole number. It is false. Okay. What do you think? Every rational number, is it a whole number? Okay, if you are thinking yes, do you think 7 over 8 is a whole number? Do you think minus 4 is a whole number? No, right? So it is false. We got this? I hope this is clear. Whenever you have to do the true and false, just remember the table. Remember this big picture over here. Try to do it once more and more. You will be able to do this, right?
Lastly, what do you think this is? Well, just think about it, because this is what we are going to discuss in our next session. Make sure you're attending the session. Take care. Bye.